A fluid is any substance or a collection of solid particles that doesn't have a fixed shape, because it cannot support itself without the help of a container. This characteristic of fluids is a result of the weak attraction between molecules, and it allows them to flow freely. Chapter 2a discusses the basic properties of fluids and how they affect the manner in which a fluid flows. One of the fundamental properties in physics is density, which is a measure of how much mass a material has per unit volume. Density is a material property, which is unique for every material, whether in a solid, liquid, or gas state. The density of a substance is affected by its temperature and pressure, although these two factors are usually significant mostly in gases. Density tends to decrease as temperature increases, since the molecules gain energy and move further apart, while an increase in pressure makes the density higher, since the molecules are being forced to be closer together. Very few solids or liquids tend to behave in the opposite manner, and one of those substances is water. This is why ice is less dense than liquid water, although it is colder. Knowledge of densities is helpful for calculating the upthrust force. Upthrust is the name given to the reaction force from a fluid on a body that is immersed in it. It is caused by the action of the body which displaces or moves away some mass of fluid. This force is exactly equal to the weight of fluid displaced. The upthrust force on a body reaches a maximum when the body is completely submerged in a fluid, in which case the mass of fluid displaced is equal to the volume of the body multiplied by the density of the fluid. A solid that is placed freely in a fluid will keep sinking until the upthrust force is high enough to balance the weight of the solid and make it float. This happens only if the density of the solid is less than the fluid's density. If the solid is denser, then it will never be able to displace sufficient fluid weight to prevent sinking. Although upthrust is usually significant in liquids, it does exist in gases. One common application is the air balloon, which is lifted by the upthrust force from the atmosphere. The hydrometer is a measuring device that utilizes the balance of weight and upthrust to measure the density of a fluid. The device sinks more in low-density fluids, and its scale gives a reading of the relative density of the fluid being examined. The relative density is a ratio which compares the unknown density of a fluid to a known density of another fluid, usually water. So to calculate the unknown density, the ratio from the hydrometer should be multiplied by the density of water. The two main flow types which describe the flow behavior of a fluid are laminar flow and turbulent flow. Laminar flow is characterized by smooth movement of a fluid in which layers of the flow do not mix with each other. One way to imagine this is if you track the trajectory of a particle in a laminar flow, you will see that the particle movement is predictable, as it doesn't change its velocity suddenly. Such a trajectory can be called a streamline. Laminar flow does not imply that velocity is uniform everywhere, but at a fixed point, the flow direction does remain the same. The other flow regime is called turbulent, and it is characterized by its chaotic and unsteady flow pattern, which means that the velocity at any point in the flow changes quickly and layers mix together. This often creates regions of high and low pressure in a turbulent flow, and it makes it hard to predict the trajectory of a particle in the flow. Many factors determine whether a flow will be laminar or turbulent. The most important factors are flow speed, fluid density, viscosity, which I will explain next, and the geometry over which the fluid is moving. If all factors are fixed, A flow transitions from laminar to turbulent as its speed increases beyond a critical value. This transition is gradual and does not happen suddenly. Viscosity is a fluid property which measures the extent to which a fluid can resist deformation, which means how easy it is for the fluid layers to slip past each other. A simple way to think of viscosity is to consider how thick a fluid is. The higher the viscosity, the thicker the fluid will be, and so the more difficult it will be for the fluid to flow. If you pour a very viscous fluid, such as honey, on a flat surface, you will notice that it doesn't spread out very quickly. This is due to its high viscosity. A fluid like water, on the other hand, would spread very quickly, due to its relatively low viscosity. Viscosity is dependent on temperature, but you need to keep in mind that the liquids and gases respond in the opposite manner. In liquids, the correlation is negative, so as temperature increases, the viscosity decreases. This happens because temperature increases the kinetic energy of molecules, and they become less tightly attracted to each other. But in gases, the correlation is positive, so viscosity increases as temperature increases. This happens because gas molecules are already weakly attracted to each other, and so any increase in vibration of gas molecules makes them interact strongly with each other, and that makes the gaseous substance more difficult to flow. Terminal velocity is the final velocity, or the highest velocity that a moving body attains when the net force acting on it during free fall is zero, which means that all forces that are acting on it become balanced and the acceleration becomes zero. So the increase in velocity terminates at this point. Free fall means that a body falls due to its own weight, and no other forces are applied to make it accelerate. In a vacuum, a body will continue accelerating indefinitely, and hence it will not have a terminal velocity. However, when an atmosphere is present, or when a falling body is in a fluid, it will experience a drag force from the air molecules or from the fluid molecules, and this force keeps increasing as the body speeds up. This reduces the net force acting on the body, since the drag force opposes the weight. At a specific speed, the drag force will be sufficiently large, and it will completely cancel out the weight, so the net force acting on the body becomes zero. If a body is falling through a very viscous or dense fluid, the effect of upthrust force becomes significant. Both upthrust and drag oppose weight, but when a body is fully immersed in a fluid, the upthrust force is constant. It is independent of velocity, since the weight of fluid displaced is constant. In this case, only the drag force or the viscous drag force depends on the body's velocity.